Okay, so take it away, Ivana.
Okay, thank you all for the opportunity to talk today about photobiomodulation and tissue repair. This is part of a research line and career that I started at least a decade ago. And what is photobiomodulation? It is the use of light to stimulate injured tissues where any light could be used as a source of energy, although the most common is the use of laser light in very low potency. So if we look at the nature, we may find some similar principles for what happens when you intentionally irradiate tissues. So natural chromophores present in living organisms, such as the retinal proteins in the eye or chlorophyll proteins, the retinal proteins or chlorophyll in the leaves that are essential for photosynthesis, right? They are all dependent on light stimuli to produce vision or energy. And within our specialized cells or less specialized tissues, we also have some photoreceptors. Very well studied one is the cytochrome C oxidase, an enzyme that is present in the mitochondria. And upon laser stimulation, accumulated evidence has shown that an increased amount of energy or ATP in reactive oxygen species in the respiratory chain when you irradiate those tissues. And those molecules are then used for triggering several pro-resolutive cascades and towards tissue repair. So what we observe after photobiomodulation may be faster repair rate, inflammation and pain control, and better tissue reconstruction. So I made a little poem to play with lasers hole in the tissues and to represent what I say. So a cell poem to the laser light. I am a damaged cell and I may not survive, but if you give me an extra power, the impossible will take a little while. So I am Ivana Diniz and I'm a professor at the dental school at UFMG, is the southeast region of Brazil. And it's a pleasure to talk to you, to give this talk to you today. Although photobiomodulation is being studied for a long time and seems promising, there is still a lot of skepticism regarding the therapy. So this skepticism is mainly related to the light protocols that vary a lot and sometimes fall out of the therapeutic window of the therapy. And another issue is the lack of a good experimental model helping to demonstrate what cells are being directly stimulated by laser and molecules as well. So we don't know much about those mechanisms of laser light. So since 2018, we have been working with a transgenic mice model that shows some stem cells in their body. So these stem cells are neuroprogenitor cells and also perivascular cells or the pericytes. So as dentists, in this research line, we were interested in using laser to stimulate dental pulp tissue regeneration to avoid more invasive treatments such as root canal treatments. So some of us may have passed through those root canal treatment experiences. That is basically the removal of the smooth and centered part of the tooth, the pulp tissue, filling its space with a plastic material. So here we can see a mouse tooth, and here a human pulp tissue removed from the tooth. So root canal treatments are discomfort and limit the survival of the tooth compared to the preservation of the pulp tissue because they lead to the loss of tooth sensitivity. So due to this, tooth becomes becomes susceptible to more severe carious lesions, since the patient will not feel any pain and will probably not see a dentist before a cavity is installed there. So the tooth may be secretly destroyed. To make a little of public engagement regarding this research and dentistry overall, we have a project called De Boca Aberta, where you can see here. A rough translation would be the open mouth. And here is a post about this canal root issue that I just mentioned with you. So in the middle of the night, tooth without soul, which would be the pulp tissue, could be secretly destroyed by invasive creatures. So root canal treatment and the reduced tooth survival. So that's why we are looking for different therapies to preserve this pulp tissue. So here we have our transgenic mice model, this one here, showing in green neural progenitor cells and in red or pink the perivascular cells or the pericytes. And what we have discovered is that when you apply photobiomodulation in an injured pulp tissue, here is like would be a horn of a pulp tissue. So when you perform an artificial injury here and you apply laser, what you see is that the tissue is more organized and you have more from those stem cells, right? Pericytes and also neuroprogenitor cells than the control, where you have a messy tissue here, and most of the times you lose pulp vitality. So it's kind of a dead pulp. Whereas when you apply laser, you have a healthy tissue here, surviving that injury that we artificially performed.
You have less than a minute, or you've gone over a little bit, so can you finish up, please?
Okay.
Thanks.
Considering that photobiomodulation has a role on the tissue microvasculature, right? Vessels and blood vessels, and it has a role on this subject. It has also increased the number of these cells, both pericytes and neuroprogenitor cells. We hypothesized that laser could be a promising therapy to preserve this pulp vitality and the life of a tooth in the oral cavity. But we still have a lot to search about this therapy. We still have to see longer times because we have just evaluated it in a short term. But we believe that laser would be the light to avoid root canal treatment and stimulate stem cell-based therapies to the dental field. We have some previous publications here regarding our preliminary studies, and they are very exciting. So our next points would be evaluate it in more robust models using genomics and everything we can. Thank you very much for your attention.
Great, thanks, Ivana. Let me